as a path difference of lambda by 4. I wrote down this for you in the beginning earlier on. Let's do an example. Two sounds of the same frequency, 170 Hertz, are produced at points A and B, and these waves are detected at point C. You need to find what are the path difference and the corresponding phase difference for waves reaching C if C is 10 meters from A and 14 meters from B. Well, there are three situations. Let's take one at a time. Alright, in case 1, distance AC is 10 meters and distance BC is 14 meters. And what are the things that we know in this problem? The frequency of the sounds, both frequencies are the same, and that is 170 Hertz. The amplitude of vibration is 0.025 meter. Well, I haven't given it to you here. Well, I meant to give it to you. That is the amplitude. The velocity, the speed of sound in air is 340 meters per second. I don't have to give it to you. You're supposed to know that. Alright, first we find the wavelength lambda of the waves that are produced. Now, how do you find the wavelength? You know the frequency, you know the wave speed. Therefore, wavelength lambda equal to V over F. That will be 340 meters per second divided by 170 per second. That is 2 meters. The wavelength of the waves starting from A and B is 2 meters. Alright, once you know that, we can now take part A. In part A, distance AC is 10 meters. And distance BC is 14 meters. Tell me, what is the path difference between waves from A and B reaching at C? The path difference is 14 meters minus 10 meters, which is 4 meters. Well, this 4 meters is equal to 2 full wavelengths, because one wavelength is 2 meters. Alright, if the path difference between the waves starting from A and B is 2 full wavelengths, tell me, are the waves arriving at C in phase or out of phase? They are arriving in phase. That means the amplitude of vibration there will be twice the amplitude. The amplitude will be 2 times this value. So as the path difference is an integer multiple of a wavelength, these waves are in phase. That means the phase difference is 0. Alright, in B part, the distance AC is 10 meters and the distance BC is 11 meters. What is the path difference? The path difference between AC and BC is 11 meters minus 10 meters, that is 1 meter. If it is 1 meter, what part of a wavelength is it? The wavelength is 2 meters, therefore this path difference of 1 meter is half of a wavelength. Alright? If the path difference is half of a wavelength, what is the corresponding phase difference? Yes? A path difference of half a wavelength is equivalent to a phase difference of pi. So, these waves are completely out of phase. The phase difference is pi. That means the resultant displacement at C will be 0. You will hear no sound at C. Alright, let's do now the C part. Distance from A to C, distance AC is 10 meter. Distance BC is 10.5 meter. What is the path difference this time? The path difference between AC and BC is 10.5 meter minus 10 meter, that is 0.5 of a meter. Tell me, what part of a wavelength is this 0.5 meter? A wavelength is 2 meter. Therefore, this path difference of 0.5 meter equal to a quarter of a wavelength. Now, what is the corresponding phase difference? The corresponding phase difference is pi by 2. Therefore, the amplitude when they meet at that point will be, well, will be 2a cos delta by 2, right? 2a cos delta by 2. Delta is pi by 2. And delta by 2 will be pi by 4. So the resultant amplitude will be 2a cos pi by 4. You can work it out on your own. There will be some sound there. It will not be a maximum. It will not be a minimum. It will be somewhere in between. Another problem. Two sound waves oscillate in phase with a frequency of 100 Hertz. At a 0.5 meter from one source and 5.85 meter from the other source, the amplitude from each source separately is A. What is the phase difference between the waves from these two sources at that point? Well, what are the given data? The frequency of the sound produced by both sources is 100 Hertz, and you know the speed of sound is 340 meters per second. That means we can calculate the wavelength. Once you have the frequency and the speed of the wave, we can calculate the wavelength. Wavelength lambda is V over F. That will be 340 meters per second divided by 100 per second, which is 3.4 meter. Okay, now tell me, the at a 0.5 meter from one source and 5.8 meter from the other source, what is the path difference between the paths taken by these two waves? The path difference of the point from the two sources is 5.85 minus 5, that is 0.85 meter. Can you tell me, this 0.85 meter is what part of this wavelength? Well, that is a quarter of a wavelength, because 0.85 is a quarter of 3.4. So the path difference between the 2 points for the waves reaching at that point is lambda by 4. What is the corresponding phase difference? A path difference of a quarter lambda corresponds to a phase difference of pi by 2. Yes? So the phase difference therefore is pi by 2. So you must be able to do these kind of problems. If you know the path difference, you must be able to find the phase difference. What is the amplitude of the resultant wave? The same problem. What is the amplitude of the resultant wave? Well, if delta equal to pi by 2, A prime is the amplitude of the waves meeting at that point. Do you remember the equation for the amplitude? The amplitude, the resultant amplitude is 2a cos delta by 2. I hope you remember from our discussion from harmonic waves earlier. So if A prime is the amplitude when the two waves meet at that point, that A prime will be 2a cos delta by 2. Now, delta by 2. Delta is pi by 2. Therefore, delta by 2 will be pi by 4. It will be 2a cos pi by 4. Anybody tell me the value of cos pi by 4? It is square root 2 over 2. So, if this is square root 2 over 2, the 2 on the denominator will cancel with this 2. So, the answer is square root 2 times a, where a is the amplitude of each wave that is arriving at C. Alright? Okay, left one.